Hi folks, this is the video segment that I'm preparing for the analysis of a composite propeller blade. Okay, so first let me show you the geometry. The geometry is shown here. Okay, and just to give you a rough idea of what the size of this thing is, the length of this is about 800 millimeters. Okay, and actually I think this diameter is 40 millimeters. Okay, and this blade is made of a composite material of 8 layers, balanced and symmetric as so, and it's made of carbon fiber material. Roughly, these are the material properties, and we are going to it is rotating about this axis X at 1000 RPM, and uh, this is why we need, because of centrifugal force, we need the density of the material, and also due to the fluid dynamics aspect of the problem, there is a dynamic pressure of 0.005 uh, megapascal, which is 5 e to the minus 6 gigapascal acting on this face. Okay. Now I'm going to import this propeller uh, as an IGES file, and the analysis is going to be done in Catia version 2018 or 2018. So if you're using an older version, there may be some minor changes. Now you will see that actually the IGES file that we import is consisting of 4 surfaces, and we're going to proceed from that point on. Okay. This was taken from Dr. Cherneyev's course, which was offered last winter. All right. Okay, so we are in Catia, so we're gonna do we're gonna import it first. File, open, and we're gonna go to this folder, and there is a IGES file there. Open it, and there we are. Okay, notice that these are the 4 surfaces that I'm talking about. First thing I'm going to do is to save this thing. So file, save management, save as. We're going to call it part 1. Okay, and we close it. All right. Now, just to show you what these surfaces are, so let me hide them one by one. If I look at this one, this is the this one is the back side. So if I hide all of these, hide, hide, and hide. So this is the back side. Okay. If I hide this and I bring the other one into the show mode, this is the front side, front surface. If I look at this, this is the narrow ring over there, and this one is the wide ring. Wide ring. Okay. So what do I give these things some names? So for example, this one I'm going to call it. Let's see now. We're going to call it wide ring. Wide ring. WR. Okay. This one I'm going to call it narrow ring. Properties NR. This one was the front surface, so we're going to call it front. Properties, we're going to call it front. Okay. And that one is the rear one. Properties, I'm going to call it back. How about back? Okay. There's a few things I want to do. If you look at, for example, this, let's look at the back one, properties. All right, I'm going to hide that. Now, we're going to need the boundary of this surface, because at some point we're going to put plies on it, and in order to find the plies, we need the boundary or the contours of the ply. So how do we do this? First of all, we have to go to generative shape design, okay? and look at the boundary. There is an icon here which says boundary right there. See that? Under the, let's see now, this one is the under the operations toolbar, there is a boundary. So we select that surface, there is the boundary, and I am going to, this is fine, but I'm going to call it, right click properties, I'm going to call it back boundary, okay? Back boundary. There's a lot of bookkeeping when the geometry becomes complicated. Obviously, there's a lot of bookkeeping. So let me hide the back one, bring the front one into the show mode, right there, and then again I'm going to use the boundary of that surface. This is going to be the front one. So let me rename this thing properties front. All right. How about getting the boundaries of these two? So let me hide this. Let me bring the narrow surface. There we are. There we are. Okay. So a boundary of that surface. Now this is consisting of two pieces, one on this side, one on the other side. So when I say okay, it tells me that these are two disjoint pieces. We're going to say keep all sub elements, and we're going to call this thing NR boundary. NR narrow ring boundary. That's what it means. And finally, we're going to bring the white one. So if I hide this, bring that one into the show mode. Boundary of that surface. Once again, there's two pieces here. Keep both of them. And I'm going to call this thing white ring. Okay, right? Properties. WR. Okay. Now, there's something else I want to do. And that is if I hide all of these, hide, hide, obviously there's a faster way of hiding 5 things at the same time. Okay, so if I bring the front, the back one into the, let me bring the, yeah, okay, the back one. Okay, so what I want to do later on is to create a rosette, and I want my rosette to follow this path. As a matter of fact, if I change the rendering here, I can see that better. So let me see now, maybe with the edges. Yeah. I want to extract this boundary here because I want the rosette to basically kind of follow the x-axis, to follow that. So what I'm going to do is I'm going to say another extract. Let's go to the extract that curve right there. Okay, and we're going to give it a name. So this one I'm going to call it the rear path, or back path. How about that? Properties, I'm going to call it the back path. How about that? Back path. It's right here. Okay, and I do the same thing to the front one. So let me hide this guy and bring the front one to the show mode. There we are. I want to extract this guy. See, let me put this thing in the isometric view. Here's the front one. I want to extract this path. Okay, so extract this path. Okay, and we're going to call it front path. Properties, front path. Okay, very good. Now, let me hide this and hide that. Okay. So what we're looking at is the front one right now, which is fine. Now I'm going to create two coordinate system, two axis system. One of them is going to be the global one because I want to know where is that the global coordinate system. So where is the axis system? Right there. Axis system is over there. And I told you this distance is about 90 millimeters. Okay, so I'm going to leave this thing here, and we're going to call this thing global one. Properties, global. I'm going to create another one. which is exactly like that, except that it's rotated about the x-axis by 90 degrees. So let's do another one. Now notice that immediately when you create another axis system, it immediately puts it at this origin aligned with that. So just so that I can distinguish between these two, let me move this coordinate system that I'm creating, the second one, to a slightly different location. So origin, create a point over there. Let's go in the direction X by some amount. So this is going to be the one that I'm creating now. It's not going to be the global one. You'll see why. Because I want to rotate this thing about the z-axis by 90 degrees. So you put the cursor on the z-axis, right-click rotation 90. Notice that X is along that line in this direction. All right, and I'm going to call this thing rotated. Properties. So when it comes to using the Rosette, this is the one that I'm going to be using. Rotated, not the global one now. Very good. Okay. Rotate, rotate it. Okay. Save everything. File save management. This is the blade geometry. Save as. Well, that's the name I'm going to give it. All right. Okay, so we're done here. Now we're going to create our material properties. Okay, to do that, obviously, well, there's different ways of doing this, but so here's the way I did in the previous video segment. So I go to Start, under Infrastructure, under Material Library. Here's the one. It's creating one. So I'm going to rename this thing Properties. Properties. Just give it a different name. Carbon epoxy. Carbon epoxy. Okay. And let's see now under the composites. This is unidirectional, and the thickness is 0.52 millimeter. 0.25 millimeter. I'm going to change my units here later on. Okay, why don't I go change the units, tools, options. Under parameters and measures, on the units, the length is millimeters. Let's scroll down. Density is kilogram per meter cube. That's okay. We have force. I don't have a force here. I have pressure, but that's okay. I'm going to change this thing to Newton. And we go to pressure, and I'm going to change this into gigapascal. Gigapascal. Okay. So once again, double click on this. We already defined its composite properties, 0.25 millimeter. You can see that. And under analysis, we're going to use a lamina. Well, it's not called lamina in Catia. It's called orthotropic 2D property. And we're going to put the stuff there. So 148 gigapascal. Based on that table that I showed you, 148 for this. The transverse Young's modulus is 10.5. Poisson ratio was 0.3. Okay, the shear moduli, this one was 5.61 giga. This one is also 5.61. This one is half, 2.8. We are not using the density is here 1800. Now I'm not doing any failure analysis here, so the strength properties I'm not defining. Say okay. All right. And I believe we have to save this thing. That is the right folder, blade composite. Okay, so I'm going to call it my carbon epoxy. My carbon epoxy. Okay, and then we say okay, and we close. Oops, I think I closed the whole window. So let me start the Catia. Oh, right there, right there. Play geometry. I accidentally closed the entire Catia program. All right. Okay. So now we're going to go to the composite design workbench and composite parameters right there. Add the material, go to the library, go to the desktop, and I had a folder here where I put my material in it. Say OK, and we say OK, and here's the properties. Okay, right there, you can see that. Okay. Now, as far as direction goes, we have all the default directions that we want, no problem. As far as Rosette goes, we're going to create, I'm going to create actually 4, okay? Except that for the ring, for the white ring and the narrow ring, uh, it's going to be exactly the same rosette. Okay. However, since I have 4 different surfaces, I'm going to create 4 different rosettes. Okay. 2 of them are the same. Okay. So add a rosette. Let's start with the one that goes with the back surface. Okay. So I'm going to call this thing a back one, the back rosette. How about that? Means for the back surface. That's really what I mean. Maybe I should call it big A C K. Okay. The axis system, remember, this is the one that was rotated 90 degrees. This is the one that we want. And 0-degree guide, the 0-degree, 0 degree guided by the curve. Now remember, I extracted these curves. One of them was for the back one. It's right here. So that's going to be my zero 0 degree guided by that curve. Okay. And the only thing that you have to make sure is, yeah, that's pretty much it. All right. So we created that rosette. There we are. So another one. This one is gonna call it front, and it's the same axis system, but the 0 degrees guided by the curve, and for the curve I use that front extracted path. Okay, and we do 2 more. So add a rosette. Axis system still the same. But I'm not going to use this is for the front and for the narrow ring and the wide ring. So I'm just going to use Cartesian. Oh, but the name of this, let me edit it. Let me give the name of this. This was yeah, I'll call it narrow ring. Okay, and the other one for the wide ring is going to be exactly the same thing. So this is redundant, but I'll do it anyways. So wide ring and same one, and we say okay. Very good. So material we already have. That's good. Okay, save it. And we're going to do this thing with the manual ply method. So we're going to create 4 ply groups, one for the front, one for the rear, one for the wide ring, and one for the narrow one. So let's start creating the groups. Okay, let's start with first one, ply group 1. Why don't I call this thing back? The back. Okay. Let me move that one out of the way. back plies group. So we can do it from the surface, or we can do it from the tree, whichever is convenient. So it's the back surface right there, and make sure that the uh, draping direction is into the hollow segment. So let me put this in isometric view. If this is the back surface, then you click on it so that it's actually, the only thing is that I'm not sure which one is which. Just a second. Let me, this one was the front one actually. So let me bring all of these into the show mode. It's easier to do it like that. Okay, put it in isometric view. Okay, let's create the first one. And this, we said it's the back. And I'll take this one away. And the surface is the back one. And notice that the back one is pointing, the arrow draping direction is pointing outward. It should be reversed, because the mold is usually, these are done in molds, and mold has to close. So okay, so that's fine. And now as far as the rosette goes, it's the back one, and that's pretty much it. Okay, so we are creating these groups. You can see that. Let's do the other one. This time we do the front, and you can see why I took the one away. So let me call this thing front. And for the draping direction, reverse it. And for the rosette, we use the front rosette. Let's do the narrow one. So there's the narrow surface. Flip the direction so that it goes inward. So this is going to be narrow ring. And take away the one. Did I reverse it? Yes, I did reverse the direction. And for the rosette, narrow rosette. And finally, this is the wide ring. Flip the direction. Give it a proper name. So that's going to be wide ring. And take the one away. And for the rosette, take the wide ring rosette. And we say, okay. So here are the ply group. Now let's start making the uh, the 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 the, the plies in back ply group. So here's the, the manual ply creation. Notice that nothing is happening because it's expecting you to go and select the group. At the bottom left of the screen, you can says select ply group. So here we are. Okay, so why don't I call these things, give these things a meaningful name. So this one is ply 1. Okay, ply 1 back. How about that? Back. Okay, and the curve, the contour of it is the boundaries that are extracted. Remember there's the boundary that are extracted. Renamed it. Okay, it's this. Okay, for the attributes, this first of all is plus or minus 45 is 90 and 0. I think that's the way it was, right? Uh, 45, yep, 90 and 0. Okay, very good. So let's do that. So this is going to be plus 45. Uh, the rosette is selected properly. We say okay. Now you have to patiently do this thing 3 times. This is the first one. See that? Another one in the same group. We call this thing, this is ply 2, right? So back. Oops, oops. Back. All right, so the boundary is that back boundary. And for attributes, this is minus 45. And of course, the rosette is selected correctly. Another one. Next one is the 90-degree one. So this is going to be back. Yeah, back. The boundary is that back boundary. and this is 90. Last one for the supply group. Back. Boundary is back boundary. Attribute 0. Okay. Now, uh, this one, it has to be mirrored because remember it's symmetric. We can do that right now. There is this icon here which says symmetric ply stacking. You click on it, and the group is right there, the back group, and it's a non-pivot, means that it was plus minus 45, 90, 0, and then start with 0, and then 90, etc. Okay, so that's what non-pivot means. In fact, there's going to be 8 of them. You can see that. As a matter of fact, in order to check to see whether we have done it right or not, we can use the ply exploder. Where's the ply exploder? Right, is this the one? Yeah, exploder. And it's the background that we created. We haven't even done the other ones yet. Okay, you can see that. This is the back face. Now, it's hard to see here, so why don't we actually make this thing smaller? Okay, right there, you can see that. You can see plus 45, minus 45, 90, 0, 0, 90, minus 45, and the red is plus 45. Cancel. Okay, very good. So we have to repeat this boring thing again for the front one, etc. But yep. So this one is going to be front. There are faster ways of doing this thing, but this is fine. So the front boundary right there, and again we start with plus 45. Okay, do it again. Right there. So this one is going to be front, and the boundary is front boundary. The attribute is minus 45. Do it again. Uh, Front. Boundary is front boundary. Attribute, this was 9, this is now 90. Last one for this group. Over here. The boundary is the front. The name, remember this is front. Front. Attributes, this is 0. You say OK. So there is the 4 and mirror it for this supply group, non-pivot. There's going to be another 8 here. And unfortunately, we have to repeat the same thing for these two. So let's start with the front one, or the narrow one. So let me call this thing narrow ring, NR. Okay. And for the boundary, we have the narrow ring boundary. See that? Right there. Attribute minus 45, plus 45. Repeat it. Let me expand this so that you can see it better. So narrow ring. This is narrow ring. NR. If you're becoming impatient, then you can fast forward this so that you don't see the stuff that I've done here, and then proceed with the rest of the work. So let's go here, narrow ring. Oh, the name is narrow ring. Okay, attribute 90. Last one in this group, right there, narrow ring. This is narrow ring. attribute is 0 degrees, and then we mirror it. So there's going to be another 4 created here. Last ply group. So this last one, this is wide ring. The boundary is the wide ring boundary. Okay. Yep. And the attribute is 45. See that? Then the minus 45. Oh, minus 45. Two more. This is 90. This is wide drink. Okay. And the last one is going to be 0 orientation. Here's the boundary. This one is WR. And the attribute is 0. And finally mirror it to get the other 4. So altogether we have 4 times 8, 32 basically plies. Save everything. Okay, so that takes care of this. I'm not going to bother using the ply exploder to plot these things. Let me actually collapse these trees. Okay, now to do the rest of the problem, the meshing, so we're going to go to, let's go to the advanced meshing tool here. And I'm not going to use a very fine mesh. This is why you may get some warning message about the size of the mesh and things like that. So, so let's start with the surface mesher. Select the back surface and make this thing. Let's start with 10 millimeters, see what happens. 10. And capture any two nodes within 1 millimeters of each other. Okay, so we say okay, and mesh it right there. See the back one? Okay, and then we say okay. Let's call this thing properties. Let's call it back. Do the front one now. So we have to exit this. Do the front one now. This is the front surface. Again 10, 1 millimeter, fine. Yeah. One thing I forgot to do, we're gonna have to fix this, and that is, remember the direction of the join. What I should have done was to join these surfaces and then make sure that when you mesh, the direction of the draping direction and the join are opposite to each other. That's one thing I forgot to do, and we have to go and fix this. Okay, so let's see. Uh, for this problem, we know that the direction of the draping was inward. So I have to make sure that when I join it, the direction of the surfaces are outward. Okay. The only problem is that uh, we're going to check the direction of the shell elements, because that's one step that I forgot to do, and unfortunately uh, I have to make sure that the direction of the normal to the shell element is opposite to the direction of the joint, or let's put it this way, uh, the direction of the shell element is in the draping direction, which is inward. I have a feeling that this arrow will guarantee that. We're going to check that. We're going to check that. Okay. So let's mesh it right there. This is fine. Exit to the sides. Okay. And notice that at the seam, there the nodes are coming together. Okay. So that's because of that feature automatic mesh capture that I asked for. And this is the front properties. Front. Do the next one. This is the narrowing. I am pretty sure this is going to work. I don't have to do the joining because the draping direction was inward, and this arrow shows you the direction of the normal. We're going to double check that, and they are in the same direction. So once again, 10 millimeter, fine, and then mesh it. See, this is a rather coarse mesh here, but I'm showing you basically the process. I'm not looking at accuracy or anything. And this is a horrible mesh. This red means that it's a distorted elements. Obviously, it went from a four-sided to three-sided, so it is distorted. So this was the narrowing properties and R. Then last one, this is the wide ring. Yep. And mesh it. There we are. Say OK. Properties, wide ring. Oops. All right. Now, uh, exit. Okay. Let me repeat what I said. The direction of in Catia, the direction of the normal to the shell element must be in the draping direction. Okay. And the way to check that is, let me save everything. File, save management. We can do that right here before I yeah, let's do that actually. So save as analysis, fine. Say OK. Now we're done here. So let's go to the generative structure analysis. Okay. Now I haven't applied any loads or anything, but I can still say, show me the mesh. Run it and show me the mesh. Okay, so you put the cursor there, right click, generate image, and I want the normal local axis symbol, Now, the direction 3 or the normal to the shell element that are created must be inward. Okay, so let's see now. How do we see this thing? First of all, let me see my surface. You go in, you see that? Direction 3 normal is inward and the draping direction is inward. And this is why it's going to work. If the draping direction and normal direction are in opposite directions, you're going to get results, but the results are not the correct ones. Okay, so these are all okay. We don't have to go and fix the joint. If you watch the previous, I don't know, 30 videos, you see that I always worry about joints. Here I forgot to join, but then I checked and normal direction and the draping direction are the same. So it doesn't matter what the joint direction was. All right. Okay, so save everything. Let me deactivate this plot. All right, so put this in isometric view. Okay, very good. Let us import the composite properties. The support, let's start with the back one. This is the back one. And we're going to do it by plies. So let's go and select the ply group, back ply group. Say OK. And symmetric. This should not be symmetric, okay? Because remember, when you make this thing, you do it in a mold, and it's not symmetric. Or you want to put this thing back. See that reference surface? It's not symmetric. This is not symmetrically placed about the reference surface. It's in this direction. It's one. So this should not symmetry should not be checked. You're going to get result, but the results are not correct. Okay, let's do it again. Let me call this thing back. It's so important to do a bookkeeping, proper bookkeeping of these, because when you debug it, if needed, then this is going to help a lot. So again, import composite property. Now we're going to do the front surface, and for the ply, we're going to say front ply group. Uncheck the symmetry. Rename this thing to be the front. Oops, front. Okay, okay. Do it again for the narrow for the surface, narrow ring surface. Plies. Select the narrow ring plies. Okay. Uncheck symmetry. Say okay. This should be narrow ring. All right. Last one. Import. Surface is the wide ring surface right there. Ply is wide ring plies group. Uncheck symmetry. Say okay. And change the name here to wide ring. Very good. Save everything. And now we're going to apply our loads and restraints. So first of all, I always suggest that hide these, because you don't want to accidentally pick an edge, and that edge happens to be the edge of a ply, which is not going to work, obviously. And I always suggest that hide this. If there anything that may block the view, hide them. So I don't think there's anything here to do that. So why don't I just hide this one too? This one does not hide the block, but in the past hide the view, but in the past 30, 40 videos, I've always said hide that one too. Okay, so this is the isometric view. So let's put the pressure on this face. Where is the load? Pressure is right there on that face, and that'll be 0.5 uh, e to the minus 6 gigapascal. Now, oh, minus, yeah. So this has to be inward. The reason that you can't see it well is mainly because, you see this? Mainly uh, because I did, it is correct direction. There's no doubt about it. But because I didn't fool around with join, I don't have much control here. I have to kind of rotate it and zoom it. See? Either that or, yeah, it's inward. You can see that. Yeah. Okay. So isometric view. Oops. That was the wrong face. I wanted to put it on the front one. That's not right. Not on the back. So I put it on the back. Uh, Let me cancel that. Delete it. Do it again. Where's the front face? The front face is right here. Okay. So let's try it again. Pressure on the front face. This one. And let's see how it looks like right now. In there. Let me change the rendering. Maybe I can see it better that way. So actually this should be negative now, because it has to press into that face. Yeah. So this is pressing into the face of the blade. So let me change this thing to a different rendering here. Let me see for a second. Let's do it from this end. Yeah, there's a face. See, this is the front face, and it's pushing inward. Okay, that's good. The reason this is turning back is because the surface is turning. Okay, the surface is turning, so that's why you may have to worry about these things if they really matter. So now the next thing is I want to clamp these two edges. So clamp this edge and that edge. They're, they're clamped to the hub of the rotor, okay? And I want to give it an acceleration or angular velocity about the x-axis, okay? Not the x-axis, the y. Oh, I can do a global x-axis or local y-axis. That's entirely up to you. So let's do that. So here is the uh, rotation force. The support is everything. Everything is rotating, so the entire part body. Now the only thing is that I don't think you can take the part body. It looks like you have to select these surfaces, 4 surfaces right there. And axis of rotation is about, this is the global one, right? This is the global one. So there's the global x-axis. See this? The global x-axis and 1,000 RPM. Okay, save everything and run it. All this mesh is not very good. I can assure you that one should not expect pretty answers here. But, okay, so it did run. Let's actually look at the deformation. There we are. In fact, you can animate it. You see that? So this is rotating, and this pressure is being applied to it due to aerodynamic forces, and this is what it's look like. Okay, very good. Let's look at the magnitude of deflection, about 6 millimeter. Okay, roughly 6 millimeter. So change the rendering here. Okay, there we are. And let's look at the stress distribution. Now, the thing is that notice that you cannot plot the stress distribution. We know that because we're dealing with a composite. So for composites, you have to go and generate it plot by plot, ply by ply. For example, if you go here, under static, yeah, right there, under static case solution, right click, generate image, under stress, filter it, under stress, and not like that. Filter under stress. Hang in there. Displacement, okay. Generate image, stress, right there. And for example, if you go to components, stress tensor components, say okay, and you double click on this and look at the von Mises, for example, and say where is it. You look at the which ply is that. This is let's do it by ply. Okay, so which ply is it? Remember, there is 32 of them. If you look at the first ply of the back or front, let's look at the front. This is front face. This is the first ply of the front face. There we are. So you can look at the von Mises stress distribution if that's what you want uh, in GPA. Okay. So listen, folks, I'm not dealing here with the issue of accuracy. I'm showing you the process. Have a good mesh, apply your apply your load and material properties, everything uh, correctly, and then I showed you how you can run this thing. So the details of this are now left out to you. Okay, good luck. As you can see, when the problems become more realistic, you spend a lot of time in bookkeeping and cleaning up and things like that. If you look at the first 40 or no 30 videos, you see that they were all just flat plates, okay? Because we didn't want to spend the time to work on the geometry, but I wanted to show you the process. Good luck.